So if you haven't finished the test yet, make sure you get that done. If you want to retake the test, you got to email me and I will give you some more to do because you need to go back and see what you missed. You need to go back and look at the lesson to see why you missed it. You need to know how to do it correctly the next time. So once you show to me that you have gone back and studied some more on it and know how to do something better by doing some more problems for me, then I allow a retake, either part one or part two, or both if necessary. Hopefully you have learned enough to be able to do well on both of those. Um, may have you do some of the practice tests or something. I haven't. It's kind of different for each one. I look and see what they missed and see what they might need to work on to show that they've improved. But let's look at this week because this week we're starting module 2. For those of you that are current and have everything turned in, we are starting module 2. So let me turn on my camera here in just a moment and look at what this week's lesson looks like here. So looking at this week, Algebra 2, if I go to the grade screen, this week, September 19th, so 2.01, 2.02. I've already done 2.01, but I didn't take the test. I got to go back and take the test. I'm behind on my student account because I've been grading your tests. But this week we have 2.01, 2.02, rational exponents and properties of rational exponents. So that's what, and then so next week we got 2, and then got 3 the week after that. So there's opportunities to work ahead if you want to, because I've already got them open with dates due. So it is there for you. But looking at this week, 2.01, rational exponents and properties of rational exponents. So I'm going to switch and put my document camera up and go over the basics of what this is talking about. Okay, so we are talking this module, this unit starting out about rational exponents, radical expressions. And when we talk about rational exponents, we're talking about something perhaps you have or have not seen. If I say x to the 2/3 power, okay, that's it's a little different, right? We're used to x squared or x to the 3rd power, x to the 1st power even, but this is x to the 2/3 power. And so with that, we have to understand how to convert that to a radical expression. Say a radical uses a square root. I'll tell you one of the rules. If we have x to the 1/2, that is the same as the square root of x. If we have x to the 1/3 power, that's the same thing as the 3rd root of x. If we have x to the 4th power, that's the same as the 4th root of x. Okay, just some basics on how it works. I'm sorry, 1/4 power. X to the 1/4 power is the same as the 4th root of x. So when we work with a fraction as an exponent, this is what it means. The denominator is actually a root. So here, what we have, this is the same as the 3rd root, since we have a 3 in the denominator. The numerator works just like we're used to. That's an x squared. So we're talking about the cubed root of x squared. When we say x to the 2/3 power, it's the cubed root. And we can convert either way. If we say we have x squared to the 1/3 power, or we have the cube root of x squared, Okay, that's going to be the same as the cubed root of x times the cubed root of x. That would be the cubed root of x squared, because we'd multiply those. And that's going to be the same thing. I'm sorry, got to put the 3 there. That's going to be the same thing as x to the 1/3 power times x to the 1/3 power, which equals x to the 2/3. That's how you step through that. So x, the cubed root of x squared is the same as the cube root of x times cube root of x. And the cube root of x is the same as x to the 1/3 power, as we can see up here. Same thing. X to the third, x to the third. And multiplying those together gives you x to the 2/3. So that's where we got to know some of the properties in dealing with exponents, because we have to know how to handle exponents when we multiply them together. So this is the product property. Let's talk about the product property. The product property. The product property says if we have x squared times x to the third, we add those together. That's the same as x to the fifth. Because x squared is x times x, right? That's x squared. X to the third is x times x times x. And if we multiply those, that's just 5 x's multiplied by each other. That's x to the fifth. So we add those together. So when we have it as a fraction, 1/3 plus 1/3 is 2/3. It works the same way, even when it's fractions or not. 1/3 plus 1/3. That's the product property. Now, a lot of times we don't have something this nice. Maybe we've got, let me use y. So I've got y to the 2/5, and I'm multiplying it times y to the 1/2. Now our product property, it says we add those together. So it's y to the what? Oh, adding fractions plus 1/2. We can only add fractions when they have the same denominator. We can't add a fifth to a half or 2/5 to a half. We can't do that. These have to be the same. So we can multiply 5 times 2 and say, well, we could deal with tenths. We can add things together if they're both tenths. So 2/5 is how many tenths? Well, we have to multiply by 1, right? 2 over 2 is the same as multiplying by 1. Yeah, let me make it look better. If we multiply by 1 and make the 1 look like this, because 2 divided by 2 is 1. 2 times 5 is 10. 2 times 2 is 4. 4 tenths is the same thing as 2/5. Same fraction. I want to make this tenth. So if I multiply this by 1, and this is going to be what my 1 looks like, 5 over 5, that's 1. Because 2 times 5 will give me 10. That's what I need. 1 times 5 is 5. Remember, when you multiply fractions, you just multiply straight across. 1 times 5, 2 times 5. That's how you multiply fractions. So 5 tenths. That's the same thing as 1/2, 5 tenths. Now I can add this. 9 tenths. So that is the same thing as y to the 9/10 power. Y to the 9/10 power. So we have to understand the product property. The product property says when we have two things that have to be the same base, they have to be the same base. I cannot take x to the second and multiply it by y to the third. That would just equal x to the second, y to the third, because I can't put those together. They have to be the same base. These are both x's. These are both y's, right? We could do 3 to the 4th times 3 squared. That would be the same as 3 to the 6th power, because they have the same basis. But I can't do 3 to the 4th times 2 squared. right? And if you did the math here, that would end up the right answer. So the product property says to add the exponents together, and when they're fractions, we got to work a little bit to make sure they're the same denominator. So this is going to be a lesson that pulls back some of your elementary years, back adding fractions together, right? That's exciting. We all look forward to adding fractions together. All right, so that's the product property. That's one of the things you need to know in these lessons, the product property. We're also being able to convert back and forth. That's going to be a big thing in here. Let's talk about another thing that is in these lessons. We have the quotient property. Spell that right? Yep. The quotient property. Well, quotient is what you get when you divide something, right? When you divide two numbers, you get a quotient. So let's say let's use the variable m this time. So I have m to the 2/5, and I'm going to divide it by m. Now let me change this. I used 2/5 last time, didn't I? Let's make this 5/6. 5/6. And I'm going to divide it by m to the 1/4. Okay, that's what I'm trying to get. Maybe you see it like this. Maybe it's the 6th root of m to the 5th divided by the 4th root of m. Could see it like that. And then we'd have to convert it to this. Right, but this is the same thing. From lesson 1, we're going to have how to convert this into this. These are the same. And then the lesson 2 is going to be what do we do with them? So how do we do this kind of math? So the quotient, that's dividing, right? So if we divide them, dividing works as subtraction. Subtraction. Product was adding, right? We add them together. The quotients, we subtract them. So we have to subtract 5/6 minus 1/4. Right? So we have to have these. So this will be the same as m to the 5/6 minus 1/4 power, which is going to be m to something, but we have to subtract those two exponents from each other. Again, just like addition, when we are dealing with any kind of a fraction, we have to have the same denominator, right? So 6 and 4, those are not the same. They would both go into 12. We can multiply them times each other. If we want to use 24, we can, but there's a number we can get to before that. Both of these would work with a 12. If we made these 12s, we could subtract that way. So to be a 12, I have to multiply this by a 1 that looks like that. 2 over 2, that's multiplying by 1. 2 times 6 is 12, which is what I want. So 2 times 5 is 10. To get 1/4 is a 12. Let's multiply that by 1. And let's make that the 1 that we use, 3 over 3. 3 times 4 is 12. 3 times 1 is 3. So now I've got 10 twelfths minus 3 twelfths. I can do that. How many twelfths do I have? 10 minus 3 is 7. So m to the 7/12 power. That would be the answer, m to the 7/12. If they want it in radical form, that would be the 12th root of m to the 7th power. That's the same. These are equivalent to each other. The 12th root of m to the 7th power is the same as m to the 7/12. Man, digging back fractions in here. All right, let's look at one other thing that we may have to deal with. Something else we need to learn in this lesson is what about when I have x to the -2 power? Well, I'm not sure what to do with that. Well, let's look at something else and how I would figure that out. Let's start with x to the 4th and then work our way down. If we start with x to the 4th, we should be able to figure out how to get there. What does it look like? So x to the 4th is x times x times x times x. I'll tell you what, let's do it with a number. Let's say it is 4 to the negative 2 power. We just made our x into a 4. So I'm going to say this is 4 to the 4th, 4 to the 3rd, 4 to the 2nd, 4 to the 1st, 4 to the 0 power, 4 to the negative 1, and 4 to the negative 2. We're going to find out with actual numbers how we get there. And this will help us understand what x needs to be. So this is 4 times 4 times 4 times 4. And this is 4 times 4 times 4, 4 times 4, and this is 4. Does anyone know what 4 to the 0 power is? I'll throw that out for the class. Anybody know what 4 to the 0 power is? Can you raise something to a 0 power? Gabriel says nothing. That's a good guess. Allie says 0. Another good guess. That's not correct, but it's a good guess. We would think so. I'll show you how to figure this out. This is 4 times 4 times 4 times 4. If I want to go from that to this, I would just divide by a 4, right? Oh, I get some ones guessing there. Because this is 64. This is, oh, I'm sorry, this is 64. 4 times 4 times 4 is 64. This is 256. This is 16. And this is 4. To get from this number to this number, we divide by 4. To get from 64 to 16, we can divide by 4. To get to 16 to 4, we divide by 4. So to get from that to the next one, we divide by 4. 4 divided by 4 is 1. 4 to the 0 power equals 1. To get to the next one, we divide by 4. So that would be 1/4. What happens when we divide 1/4 by 4? We get 1/16. So 4 to the negative 2 power is 1/16, which is the same as 1 over 4 squared. You see that pattern? This is 1 over 4 to the first power. This is just equal to 1. So what happens when you have a negative exponent is you move that down into the denominator and it becomes positive. So if I have x to the negative 2 power, that's the same as 1 over x to the positive 2 power. I just move it in the denominator and it becomes positive. 1 over 4 squared is 1/16 because it was to the power of negative 2. So that equals x times x times x. That equals x times x. That equals x. That equals 1. This equals 1 over x. And this equals 1 over x times x, or 1 over x squared. To the 0 power. 941 to the power of 0 equals 1. 2,478,111 to the 0 power equals 1. Anything to the 0 power equals 1. So there we go. Mr. Brock to the 0 power equals 1. A cat lying on top of a dog, parentheses, to the 0 power equals 1. Just anything. I'm saying anything to the 0. I'm being a little silly with that, but just want to get the point across that anything to the power of 0 equals 1. So that's an easy one. If this is all in parentheses, Mr. Brock to the 0 power, it equals 1. 941 to the 0 power equals 1. Anything to the 0 power. So that's an easy one. That's a rule right there. That's a rule. X to the 0 power equals 1. X can be any number. Any number to the 0 power. So if we understand this, that anything to the 0 power equals 1, if we understand anything to a negative exponent, we can just move it below. So let's say, for example, here, I'm going to put it on another page. If I have x to the negative 4th times y squared, that is the same thing as y squared divided by x to the 4th. Because this is a positive exponent, it stays on top. That's a negative exponent. So I move down here, it becomes positive exponent. So nice little trick of negative exponents. Yes, Gabriel, question?
What if they're both negative?
Good question. X to the negative fourth, y to the negative. That's the same thing as 1 over x to the fourth y squared. Just move them both to the denominator, which just leaves a 1 on top. Because we divided those out. There's nothing left but 1. So good question. They're both negative. So that's how that works. So the big things in this whole lesson is being able to manipulate negatives, being able to understand when we have x to the 1/2 times x squared, what to do with that. Right? That's the product property, which means we add those. Means that's x to the 2.5 power, or 5/2 if you don't mind improper fractions. Right? 2.5 or 5/2 is the same thing as 2.5. But you have to add those together. When we divide x to the third divided by x squared, that's the same as x of 3 minus 2, which is the same thing as just x to the first power, which is just x, because we subtract. So the product property and the quotient property are the two big things, where we add here, we subtract here. And then, of course, the converting, we have x to the 1/2. It's the same thing as the square root of x. If we have x to the 5/7, that's the same as the 7th root of x to the 5th power. Being able to go back and forth. If we have the 8th root of, let me just throw it, if we have 2x to the third, that's the same as 2x, and that's put in parentheses because it's all underneath there, to the 3/8 power. If the 2's out here, that changes it. Then it's 2 times x to the 3/8 power. On this one, that only the x is taken to the 3/8 power, and this one, 2x is taken to the 3/8 power, because the 2x is also underneath there. Here, the 2's out front. So remember, use parentheses when you need them. If that 2 is to be included, make sure it's included. Put the parentheses around it. So going back and forth between those, we need to be able to do that. So questions on this? Of course, your lesson is going to give you more examples of that. Your lesson will give you some practice problems doing that. And of course, just give you more examples with different letters, different numbers. I think the biggest thing that you may struggle with is it's probably been a while since you have dealt with adding and subtracting fractions, finding common denominators. We've kind of gotten out of that habit. You came out of geometry last year. You didn't spend a whole lot of time working with finding common denominators in geometry. Hopefully you hit on it a little bit from time to time, because there's places we do that, but not something we spend a lot of time on. So taking 5/6 minus 1/4, right? Those type of things. Finding common denominators. So that is the big thing that you may struggle with. But just if you need to, Google up a video on finding common denominators. Google up a video on adding fractions or subtracting fractions. If you need to go back and give yourself a fraction refresher course, feel free to do that. Don't be afraid of fractions. They're just numbers. They're just numbers. They're just numbers that are parts of numbers, right? 5/6 is not a whole 1, but it's most of a 1. It's 5 of the 6 pieces of a 1. If we cut a 1 into 6 pieces, we got 5 of them. That's 5/6. So don't shy away from the fractions. We're going to jump into fractions big time in lesson 1 right off the bat. We're going to be right there rolling around in them. So that is it. That's all I'm telling you this week, because that summarizes both lessons really nicely. So if you're caught up, I won't have to see you on Wednesday if your grade's over 70%. If you don't have the test done, or Wednesday, if you don't have everything done by Wednesday, or if your grade's below 70%, then we will meet again Wednesday. Now, this week, Friday is a B day, so Wednesday is the only other class we have this week. You are welcome to come Wednesday, even if you don't need help, because I will come to class. So come at the beginning of class. Don't wait till the end because if no one's here, I'm not going to stay. But come around at the beginning of class, and I'll be happy to help you. But otherwise, I will let you go.
Let's get out of here. Word to your multiples.
Math, math, baby.